We're starting with a lot of problems here at the generation container. We're now operating on the bypass mode whereby all the gen incoming is going direct to the load because we have a problem. When we turn into the other mode where it's the ordinary one, we still don't have power that goes to the grid. You can see from this switch, the load breaker switch, the load on-off switch is on. And we'll be moving to the multi-cluster to troubleshoot exactly what the problem is. We do have power that is coming from the generator, and hence the generator power comes in and gets here, implying that we will test these terminals, line 1, line 2, line 3, and the neutral, so that we are able to determine whether there's power that comes to this multi-cluster from the generator or not. From the first ones, we realize there's power, 233.1 from line 1, 228.7 from line 2, and 229.2 from line 3. That is generator feed-in to the multi-cluster. Then the feed-in comes to the generator contactor, and hence we determine whether the contactor is getting supplied by power. We verify again, still 233.1 for line 1, 228.6 for line 2, and 229.2 for line 3 and neutral. And now we want to determine whether the ground and the lines have some good power that we can get, because it's always supposed to be 230. Line 1 and ground is 233, similar. Line 2 and ground is 228.9, and line 3 and ground is 229.3, implying that we have all these grounded properly. And as we get up, we'll check at the cause of this contactor whether we do have power there. We realize that we have 232.9, as we can see. So we're having the cause of the contactor powered from the generator, meaning we are testing whether the contactor is on now. We realize, yes, 233.0 for line 1 and neutral, 228.8 for line 2 and neutral, and 229.3 for line 3 and neutral, implying that on this bus we do have power. However, from this bus, from these breakers, we're supposed to be having generator feeding this contactor, and this contactor is the one that supplies the load through the generation container and to the grid. So let's check the input from the generator whether it comes into the contactor. Line 1 and neutral, 233.0. Line 2 and neutral, 228.8. Line 3 and neutral, 229.4. Okay, we confirm that this is fed well. It's having power. But from here, it's supposed to pass through this. Let's check whether the coils are energized. Maybe the coils are the ones that are not turning on the contactor. We realize the coils are energized, is 233. Wow, so what is happening? Let's check whether the contactor is bringing down power for us to use from the loads. So from line 1 and neutral, we realize 2.19, no power. Line 2 neutral, no power. Line 3 neutral, no power. Line 1 and ground, no power. Line 2 and ground, no power. Line 3 and ground, no power. Implying that the reason why we don't have power getting to the load is because we have this contactor that is faulty.
Not energized.
It's energized, the coils have power, but it's not turning on. Thus, the solution is possibly a replacement of this contactor, and we see how things go in the near future. The initial case was with these breakers, these are fuses, but we identified that this fuse,
One fuse was faulty.
FT105, was faulty. We found out replacement and put in a new fuse, and it's now function, as you can see the lighting down there. Thus, the solution is not in one joke. we have to get the supply of a contactor in order to progress. Thank you.